Hello, my name is Christopher Skack, and I am the Applications Engineer for Signal Source Products here at Tektronix. Today I'll show you some features on the AWG 70,000 series. Before I talk about today's topic, I'd like to give you a general overview of the AWG 70,000 series. This is our single channel model. We have also a dual channel model. This one's 50 gigasamples per second, up to 50 gigasamples per second, variable clock rate. A differential output of 1 volt peak to peak, or 500 millivolts single-ended. And then we also have marker outputs here for use for trigger or for using as a pattern generator. It's basically a digital output that we have on. We have 2 markers per channel. Easy interface so that you can do everything from the front panel. You don't need a PC to run the instrument because there's a PC built into it running Windows 7. We also have 16 gig of memory built in as an option, and we have 10 bits of vertical resolution. So we have plenty of resolution in our DACs for very complex waveforms. This is a very general purpose tool, but you're really used in very high-end applications where you really need to create waveforms that are very specific in nature. And a lot of people use AWG to duplicate real-world conditions rather than trying to go out in the real world and look at signals. We can create them on the AWG, and that way we can provide that into your device under test to validate that your instrumentation or your product can indeed support real-world conditions. So at this point, I'll go ahead and start my demo. Today's topic, I will be talking about the sequencer. The sequencer is a capability on the AWG to play multiple waveforms in a sequence. Think of this as similar to an MPEG player where you're playing songs. Instead of songs, we're playing waveforms. So you see here in this display here, you can see that we have 3 waveforms in the indexes here. And we have a few different options that we can do. So we can, first we can wait for the waveform by waiting for a trigger event to come in. Now a trigger event can come in from the external input from the rear of the instrument, or it can be done by the front panel by actually pushing the force trigger. And then what it will do is play whatever waveform you have in here. I have picked the waveform from my list here of sequences in this list. And then you can define whether you want it to repeat that same waveform over again. You can repeat it up to over 1,000,000 times, or you can set it for infinite, such that it will play forever until you, in most cases, use an event trigger in order to go on to the next step or go to a particular step that you want to go to. So this is used quite often where you're running a particular waveform. You want to test your system with that waveform, and then you want to go on to another waveform afterwards. And then you can specify where you want it to jump to when you get this trigger event in. So you can say next, and it will go to the next step, or you can go anywhere within the 16,000 indexes that are available in the memory. If you don't use the event jump, you can also specify if you just want it to jump to a particular waveform after this waveform has finished. So you can do a lot of definitions in the particular setup. Okay, at this point I'd like to show you actually running a sequence. So first of all, I'm going to change the sequence a little bit. And in order to edit the sequence, you have to be in this sequence tab. So if I select the wait statement here, I'm going to go ahead and change this to waiting for a trigger. So until a trigger occurs, it won't play this waveform. Once a trigger does occur, then the waveform will start playing and it will repeat infinitely. You can also, on multiple channel instruments, you can have several tracks so that you can pick the tracks that you want to play on each channel. You can have independent tracks for each channel. The waveforms can be different lengths in the different channel. but they do have to be running at the same sample rate. The repeat count I've set for infinite, as I said earlier, and I'm going to wait for a trigger A event in order to move on to the next waveform, which I've defined here. And it'll tell you how long the waveform is. There are limitations as to running the sequencer. You need, on a single channel box, you need at least 4.8 or 4,800 points, or on the dual channel box you need 2,400 points. And when you're playing, we can actually see what the length is, including the repeats. Because we have this set for infinite, it doesn't know how long the time's going to be. So another thing I want to show you is that we have a feature that allows you to specify when you want it to jump when you're doing a jump. And here you can jump immediately while waveform's playing, or you can wait till that waveform is finished before it jumps. And we also have the capability of what's called a pattern jump. And this is a 256-bit pattern capability on a 15-pin DIN or connector in the back of the instrument. And so you can specify what index you're going to go to when you get that event. So you can enable that too. So at this point, I'm going to go ahead and go back to the home menu. And this is where you actually play everything. It's from the home menu, either a waveform or a sequence. And here you can see it's waiting for a trigger. It's got a T here, waiting for this trigger to occur. And then the sine wave will occur. So I'm going to go ahead and show you. Also, it shows you what step you're running. So you can see that we're at step 1. And also gives you indication of what sample rate you're running at and what amplitude. Now this amplitude is single-ended amplitude. It's only the positive or negative end will be 500 millivolts. Differentially, it'll be 1 volt. One other thing I want to mention is that before I play this is that under the settings and then under the channel 1 or channel 2 if you have a multi-unit box, you can specify your output when it's in an idle state. So while we're waiting for a trigger, you can specify either 0 volts or you can specify the first point of the waveform. So for instance, if you want it to wait at a DC level, you can basically build a waveform with a DC level in it, and it will use the first point of that waveform in order to, and during the idle state. Or you can specify 0 volts. Most people prefer to use 0 volts. We hope in the future we can actually specify different levels of DC here. But 0 volts is good because then you don't have to worry about damaging any components. So now I'm showing you basically the scope display. And as you see, as we mentioned just a minute ago, we're sitting at a DC level right now. So in order to go to the next step in the sequence, basically I've got it set up for trigger B. So on the front panel here we have a force trigger button. So I'm going to go ahead and force a trigger. And you see the sine wave comes up. So as we mentioned before, it's basically repeating infinitely until we get another event. And I've set this event to go to the next waveform. And this is set up for trigger A. So I'm just going to push the trigger A force trigger button. And you see now we go to the triangle. And again, it's set for infinite, so it's going to continue to play this waveform infinitely. And then if I hit the A button again, you can see that it goes to the square wave. So again, it's a very simple concept. It allows you to go through many waveforms. And what we can do also is, say you want to go to a particular waveform in the list of waveforms that you have here, rather than going through them sequentially. You can pick a waveform number and then go to that particular number. So if I put in 3 here, I can go ahead and select jump now, and it goes to the square wave, which is index 3. And you can also use a general purpose knob if you want to just scroll through these events or these indexes. So let me close this. So let me go ahead and force a trigger again to go to that's waiting for a trigger again. We're at the first waveform, so I'll have to hit B to start the waveform. So what you can do is you can do a force jump, and you can you can do it when the number changes, basically, rather than just jumping independently. And you can also specify some other criteria in here. So this was just a quick example of what you can do with the sequencer. Here I've loaded a little bit more complex waveforms. In this case, it's a serial data application where first part of the sequence is used for putting the DUT or the device into a loopback mode, and then actually running waveforms that have the jitter content provided so that you can make sure that the device works in compliance conditions, where you have to add a certain amount of jitter, a certain amount of ISI, a certain amount of random jitter, and then combine it all into the waveforms and test it and make sure you don't get any bit error rates. So this is a good example of one of the applications that the sequencer is used for. Like I said, many other applications too. In this case, I actually use the trigger here from one of my markers. And the nice thing is we can define either one marker or two markers active so that you can again use the markers for your triggers in the sequence. So hopefully this was an example, a good example of how to use the sequencer. There's a lot of things you can do with it, and hopefully you get a chance to use one of these instruments. Thank you.